Okay, the participants are still coming in. We might want to give them a moment or two before we start our talk. Just as you're coming in, participants will be on mute for the duration. If you have questions for the presenters, please put that in the Q&A box. We will be answering questions at the end. Use the chat for any technical questions for me, and we will try to help fix you up. The best view option, if you go in there, there's a setting at the very top right, it says view side by side so that you can see the presentation alongside the speaker. Thank you, and I think we might be ready to start, guys.
Okay, I think I'm first up on the list if I'm right. So I will share my screen. Sorry, give me a moment while I get this set up. Okay, I think it actually did the right screen that I wanted. So welcome everyone to the historical mapping session. I'm really excited to be here, not the least of which because I am actually not a historian, I'm actually a biogeographer. So my name is Michelle Tobias. I am the geospatial data specialist at UC Davis Data Lab, where I do spatial data science. And this project that I'm going to tell you about today is a project that's been going on for, gosh, almost a year now. And we're just wrapping it up. And it is a really interesting project because it is a bunch of people came together to work on a history project, just basically because we like old maps and we thought this would be fun. And we've actually discovered some pretty interesting things. So the title of my presentation is Old Train Maps, the Many Routes of California's Central Pacific Railroad. So I'll be your main speaker today, but I'm also joined in our session today by Scott Sibbett, who will be available to help answer the history questions that might come up. I can handle the technical GIS type questions, but Scott will be my backup for that. And then Darcy Bostic is one of our co-authors as well, who I don't believe is joining us today, but she did a lot of work on the technical side of this, so I just want to recognize her. So the goals of this project were to look specifically at where the Central Pacific Railroad route went and what was the logic behind that, and how did the plan vary over time. So the Central Pacific Railroad is a stretch of the Transcontinental Railroad that goes from Sacramento up to the Nevada-California state line. So that's the part we're focusing on for this particular project. So we're looking at how that planned route changed over time and how what actually got built. So the methods that we used to do the technical aspects of this project were a fairly straightforward georeferencing project. So we started with image preparation. We scanned our images, or we got folks with really good scanners to do the scanning for us. We did a little bit of processing in GIMP. So when things needed to be mosaicked or overlaid and stitched together, we used GIMP for that. That's an open source photo editing software. So it's free and open source. That makes it easier to work with because cost. And then we did our georeferencing process in QGIS. So we're using the QGIS georeferencer. And georeferencing is the process of taking a scanned image and referencing it to the real world. So that way the map, when you put it into a GIS, finds its own place and sits where it should in the world. So, you know, all of the rivers line up, roads line up where they should. And then finally, after we did all of the scanning and georeferencing, we used QGIS as digitizing tools to digitize the railroad line. So we traced where that railroad was in each of the maps so that we could compare them all together in the same view. So I want to talk a little bit about the maps that we used. So we have 3 time points. The first time point is 1861, and we have 2 sets of maps for this. So the first one that we looked at was what we call Judah's vellum map. So this is a map composed by Theodore Judah. And this was a section, 4 maps on 1 long sheet of vellum. So it's this giant roll of a map, 66 feet long. Stanford University scanned it and put it on their website, and we were able to download that. You can download it too. I can pop the links in the Slack channel when we're done. So you can go and take a look at that. You can grab it if you want. And then we had to, there's 4 sections of this map, but within those 4 sections, 2 of the sections actually have 2 maps that are kind of arranged so that they fit. And so we ended up having to break those apart, remosaic them in GIMP, and then georeference them from there. The other set of maps that we used is a set of paper maps that were composed by Theodore Judah. The vellum map that we started with, the big long one, actually has a geographic gap in it in the middle. And the 10 maps that my co-author Scott found at the California Secretary of State's archive fit precisely in that hole. It was amazing. You'll see, I'll show you a map of how these all fit together in a bit. But so we're pretty sure that these maps fit the hole that are in the other maps. So we're putting them together as one time point. So these 10 maps had to be mosaic together. So they made one image out of the 10 images, and then we were able to georeference that. We tried to do them separately. We don't have enough tie points, so we had to mosaic first and then reference the whole thing. The second time point we're looking at is another map of the plan for the route by Montague from 1868. So this map was composed by Judah's apprentice, and when he passed away, Montague took over the project. And so there was one map that we found. This is a very large map as well, but it's one sheet of paper that was at the Secretary of State's archive, and we were able to get that scanned at 400 DPI. They couldn't scan it at 600 DPI because the file was too big. But the good news is it's still readable at 400 DPI, and it's a massive file. So we probably didn't want it any bigger than it is. So you can see an example of what this map looks like. It's very big. It's not as big as the 66-foot one, but it's a fairly large map. And then the final time point, we used USGS topo maps from 1891. So we're considering this the as-built. So this is where the railroad got built in its final position and then mapped by the USGS. Fortunately, these maps were already scanned and georeferenced by the USGS, so we went ahead and used that as is. We didn't have to do any georeferencing. So the georeferencing process had some common issues amongst the maps that needed georeferencing, mainly that these are technical drawings meant for engineering, so they don't have a lot of usable tie points. The information, it doesn't include much information away from the edge of the railroad route. So we don't have things like cities or streets or things like that to use as reference points. So we had to concentrate our efforts around the railroad. We also found that in the first map, the vellum map from the first slide I showed you, that the public land survey system markers on that are largely inaccurate. They were guessing at where they belong. So when I originally tried to georeference it to the current public land survey township and range system, it didn't work. It went to a really wrong place and things were missing. So we found out pretty quickly that only one section of that map was able to be referenced to the public land survey system. So the solutions we found were to use tie points on the railroad, which was less than ideal. So we ended up having to make sure that when we used railroad reference points, that they were very clearly not moved. So we couldn't use reference points from sections that had moved between the plan and the as-built. So it wasn't ideal, but it was the only options that we had. And then finally, we also used a thin plate spline transformation, which has a lot of flexibility. That helps account for things like shrinkage in the map, and also the fact that these are technical engineering drawings and weren't necessarily, they don't necessarily have a map projection to them because they are intended to be used in a different way. So the thin plate spline allowed for a lot of warping and moving, and sometimes it's called rubber sheeting, so we could like stretch places in it and make it fit really well. So it wasn't my first choice. We tried to use a less complicated transformation, but this ended up being the best choice for this particular set of maps. So the final part of this process was to digitize. So we took our scanned georeferenced maps and we traced out the line of the railroad in each of the maps for the 3 time points, just using the standard digitizing tools in QGIS. So the results was we ended up with 3 railroad locations at 3 different time points. And you want to see maps because you're here for maps. So here we go. So these are how the 4 sets of maps fit together. So you can see sort of a little bit about the scale of these and how they fit. And you can see that the pink and the orange sets of maps, those are from the same time point from 1861. So those were two sets of maps that we believe depict the same thing at the same time. But that's not 100% guaranteed just based on the information that was on the maps. But it seems too good to be otherwise, so we're going with it. So some of our results, places where things really differed, I won't have time to talk in detail about all of this, but just to give you a quick overview. This is the section, the original end of the railroad was intended to be not in Sacramento. So it shows in the maps that they planned on ending it sort of west of Auburn and Newcastle, but eventually that got changed and went all the way down to Sacramento. So that was the most interesting thing to start with. It was the biggest deviation in the plan versus what got built. And then here's another spot where the plan for the railroad, the pinkish red line, planned on going on the other side of a river canyon. And when we were looking at trying to figure out why, we found that right where that the square is for the city of Alta, it is a really steep canyon, and you actually can't get a train car across that canyon without building a bridge. So if you look really closely at the topo map that's underneath that, you can see that it's really steep. And so that really didn't make sense in reality. So that's why it went on sort of the southeast side of the canyon instead of where it had originally been planned. And again, here's another section where the plan was a little bit more conservative, and they ended up having to go further out in order to handle the grade of, in this case, Cold Creek Valley. So conclusions about what we learned. This is the first time these maps, this particular set of maps, has ever been overlaid at the same time. They may have at one point been in the same room together back in the 1800s, but this is the first time that all these maps at different scales have come together in one spot where we can actually compare them and see them together. And this allows us to tell new things and new stories. This actually helped us understand the role of Theodore Judah and his apprentice Montague a lot more, and put him in a sort of more even standing with some of the other railroad folks that you've seen throughout history that, you know, get a lot of even press even today. There's a lot of documentaries talking about, like, you know, the Crockers and things like that, but Theodore Judah played a big role in this, and these maps help us understand that. The other thing is that georeferencing is a challenge, especially with old maps, and that perfection isn't achievable, but it's still worth doing. Even if things don't line up 100% right, we still have learned a lot from this process about where the plan was versus where it got built. And I really can't help but think about what Judah and Montague would think of this, taking their maps and putting them into a computer and laying them over each other. I think they would be fascinated. So I know, moving quickly, but I want to say a quick thank you to Curtis Carroll, who helped a lot with this project. The Secretary of State's archives did a lot of searching for maps for us. They helped a lot and uncovered some stuff that we didn't originally know about, so that was really helpful. Also, the Maptime Davis community was very helpful in letting me bounce ideas off of them, and also a shout out to Stanford Libraries for scanning this very impressive long map and not knowing what people would do with it. So that is my Oscar acceptance speech for that. I'll pop some links into the chat too. We have a web map where you can play with the data and kind of zoom in and pan around. And I will put some of the links also in the Slack. Actually, I'll just put them in the Slack workspace so that that's there for you. So you've got that. So I think that's probably about the time that I have. So I'm ready to turn that over to the next speaker, and we'll do questions at the end, I believe.
Okay, we are having technical difficulty for Pat, the second speaker. So Ryan, are you ready to go with yours?
Sure, I can go.
Okay, feel free to share screen when you're ready.
Okay, let me get that set up. Okay.
I just wanted to say, I think I'm on. Can you hear me?
Yes.
Yes, I can hear you.
Great. It's a Zoom crashed Chrome, and it crashed Firefox twice. So, yeah. So I think I can finally see your stuff. So Brian, at least I can see yours. So I'm sorry I missed the other one. I spent the whole time trying to get it
Oh.
restarted. So
Oh, shoot. I'm so
sorry about that.
It's being recorded, so you can watch it later.
That's-
Right.
Yeah,
So-
no, but I can't ask any questions now. Sorry, Ryan.
No problem. All right, so I'll get started. This is going to be a kind of a whirlwind tour of digital gazetteers and GIS. And so it's entitled Space, Place, and Linked Open Data, Digital Gazetteers, and Digital Humanities. This will be probably more of a cheerleading session about these technologies than an actual project overview like the last talk. So we'll just get started. I'm going to talk a little bit about digital gazetteers, about what it means for humanities, about modeling space, place, and how we use it. And then about linked open data, which is how we actually tie all this stuff together. And then if there's time, show you actually a little bit of maps and research about what you can do with these technologies. So a very basic problem to basically anyone who studies humanities is, what is a place? And we're very familiar with this, that we have different ideas about what a place is, different names. Like, how many names are there for New York City? You know, the city, New York, the Big Apple, the city that never sleeps, etc. We have different ideas about locations. Like, where do you put a dot for any one of the UC campuses? Is it on the president's office? Is it on the football stadium? Is it somewhere else? Different ideas, again, about representations of place, even definitions of what it is. And as humanities people, we know there's a lot of different viewpoints and emotions that go into places as well. And so this is all very familiar to us, but it becomes difficult when we want to map something, where we just want to put a dot on a map, all of our wonderful, complex ideas about places. Well, how do we actually do that? Well, one of the ways is a gazetteer approach. And basically, if you're not familiar with gazetteers, the very basic definition of them is they're lists of place names. They're often derived from or otherwise related to maps. So anyone who's seen a map index, that's kind of a gazetteer. And what it does is that each place name has a unique identifier. That's like an ID number or some other thing to differentiate it from another place. So say Athens, Greece, and Athens, Georgia will be differentiated because of the name or maybe some kind of number. What this allows us to do is actually have different definitions and views to the same entity, that we can say, well, this is the entry for Athens. Here's a bunch of stuff about it. And here's what other people have to say about it. But we're still talking about Athens, for instance. And what's great about this too is that we can have gazetteers that list unmappable things. That places, say for archaeology, places we can't find, we can't locate, maybe more conceptual ideas. And these can all be part of a gazetteer. As a sample of that, actually, gazetteers can also be indexes where, again, we have a map grid. So like Athens is at G5, or New York is at X20. We've all been kind of familiar with this. And again, there's a lot of additional information that you can have. And here is an example of one from the Barrington Atlas, which is a giant atlas. It's about that big by that big. You can spend $500 to buy it or $10 to get the iPad version of it, your choice. And what it comes with is actually this thing called a Map by Map directory, which is a gazetteer. You'll see here we have grids, we have names, we have some additional information about it. And this is what most traditional print gazetteers kind of look like. Again, names, where you find something, some very basic information. And that's all well and good. But let's move beyond it a little bit into digital gazetteers. And what's really unique about moving this thing from print to digital is that we really open up a lot of possibilities. That instead of being limited by print, there's now really infinite ways to talk about gazetteers and how they're connected to each other. That we have all of our digital gazetteers are generally based on linked open data models, and I'll talk about that in a minute. And what is also kind of unique about them is they're not GIS. Gazetteers, even though they have spatial information, are not really mappable on themselves. What they are again, lists of things that you can then associate with other data to map them. So as an example of that, this is a project I did looking at all of Greek garrisons mentioned in all literature, epigraphy, coins, inscriptions from 600 BCE to 200 CE, which I then associated with different places and gazetteers. So you'll see names of places here, the kind of types or what they are, and then you'll see this Pleiades ID column, and I'll talk about what that is in a minute. And these are all information that I have on each one of these places. I have quotes, I've got all kinds of things, but it's all put together in this gazetteer, where each thing has its own unique entry. I know exactly where to find it. I can disambiguate it from other things. And what's really kind of fun about this too is that gazetteers are not necessarily just spatial. And this might get me into trouble with some other gazetteer people, but really this approach could be applied to anything that we're doing with humanities. That anything that we're talking about, here's an entity, whether it's spatial, conceptual, or even a person, and how it relates to other things. And what's cool about this is you can do things like this gazetteer of time periods. It's called Periodo. And what it does is take definitions of, say, the classical period, and you can see it here as different kinds of definitions, where one data source will say the classical period is from 479 to 351, another one from 480 to 351, and so on. And it actually just collects these all together to figure out what is kind of a community definition of period names. And so this is something that is fairly interesting and can be applied to a lot of different contexts. And so what does this mean for you if you're into historical mapping or humanities mapping more generally? Well, if you make your list of place names, if you make your own gazetteer, you can actually match these to different ones that are out there, there are general ones and there are specialist ones. And I'll give you a few examples here. One of the most famous general ones is called GeoNames. You can find it at geonames.org. It has over 11 million modern place names. It's all open access. You can browse it, you can download it, you can query the database. What it does is, you can see a screen here, you just put in whatever name you want, and in our case, Southern California, and you'll see that it actually has an entry for Southern California. It has an ID number, it has a longitude and latitude, and some other information. And so what you can do is take your list of things and just do a simple database search back and forth and get all of this information from GeoNames, which will allow you to map a lot of locations that you may have. There's also more specialized ones. Pleiades, which actually I'm an editor on, started for the Barrington Atlas data set. And what this is a very focused on the ancient world, has over 36,000 ancient places. And we're really central to a lot of linked open data, which we'll talk about in a minute. What Pleiades allows you to do, let's see here if I can add it from, let's go to the next slide. Do you want to see the next slide, or am I frozen? There we go.
I'm still
So this
seeing,
is
oh,
the
there it goes.
coverage of Pleiades. You can see that it's actually fairly global in scale. It's not just limited to the Mediterranean. So I'm having some issues, I guess, at the site. It wouldn't be digital humanities if the computers actually worked correctly all the time. And hold on a second here. This is very intense stuff. What Pleiades does is it has this kind of coverage. It also gives you the API that access information and allows you to basically download it and create on your own system. Another gazetteer, which if this ever catches up, I'll show you, it's called the World History Gazetteer from the University of Pittsburgh. And similarly, it also has coverage as names of records, and it's worked for a world historical pattern. I think we can get back to business.
Ryan, I'm so sorry to interrupt.
And so these are just 3 gazetteers. Now, what these are all built on is what they call linked open. Yes.
I'm so sorry to interrupt, Ryan. Is it possible for you to turn off your video? The audio is becoming very choppy and it's very hard to hear you. Maybe by turning off your video, it would allow the bandwidth to pick up your audio.
Sure. No problem. Sure. There's that.
Oh, it's still a bit choppy at my end. Sorry.
It's choppy for me too.
My apologies for having internet trouble. right, can you actually hear me at all?
I'm not hearing very much, so sorry. Do you want to call in? I can give you that information, or it was sent to you in the welcome email. Maybe we can switch to our next speaker, although it looks like she was knocked off the call as well. Darn it.
All right, can you hear me at all?
Oh, the audio is much better now. Yes.
All right, well, it looks like we're having difficulty actually sharing the screen or doing anything that is visual, which on maps is interesting. Let me see if I can actually pick this up. But did you catch anything about how it's built on linked data?
I'm so sorry. Could you repeat that? Because you're breaking up once again. Okay, guys, I'm so sorry. I think we've lost Ryan. I will send him a private message and see if we can get him back. Pat, if you can hear me, are you ready to start yours?
Well, I'm certainly going to try. I'm not exactly sure how this is going to work out since this program has now crashed on me 4 times in a row.
Oh dear.
So I'm not exceedingly optimistic about how well this is going to work. So I'm actually going to go to, let's see, I have to start screen sharing. Share screen. Here we go. And can everybody see this?
It's still showing up as a black screen, but it says started screen sharing, so maybe we give it a moment to
Okay, all right.
process.
Yeah. I have no idea. No, because Ryan started, all of a sudden his voice started to crackle. Did that happen to all the rest of you?
Yes, I'm afraid it did.
Oh.
Let me send him a message. Oh dear. And I'm still not seeing your screen just
No,
yet.
my screen has now gone completely black for me. So at least I can hear you, which is better than before.
Oh, no.
No, I mean, I'm actually staring at my own reflection in my screen. So I'm not sure how this is actually going to work. What I can do is I can actually start by talking a little bit about this project, which is one that I've had on the back burner for quite some period of time, but I've been working on it episodically on and off for a number of years. And with COVID stopping all of my research, which is primarily in European archives, and for this talk, a lot of it in the British Admiralty archives, which are located in the naval base in Portsmouth. And that access, of course, is completely and totally denied. So what I've done actually is I've looked at a series of British Admiralty nautical guides, sailing directions, and maps for Africa. But that's my main area of interest is in West Africa, because, can you guys still hear me?
Yes, we can.
I'm not seeing anything either. So I don't know.
I'm afraid not. If you have time while you're chatting, you could send me, you have my email, you can send me the presentation and I can start sharing it. We can try that.
Well, it's not actually a presentation. It's actually 2 very large maps. that
Oh, I
I'm going
got
to
you. Okay.
out. So one is 4.4 megabytes and the other one is, I can try sending it to you, but unfortunately I have to have a screen in order to be able to send it to you.
Why don't you stop screen sharing and
Let's see what will happen. I have to
Yeah.
hit, I have to go to Task Manager and see if I can do that. Oh,
I have a quick question.
there
Sure.
it is.
I have a quick question. Can you hear me?
yeah.
Okay, do you hear a cow? I don't know where that cow is coming from. I went to
Cow.
Davis, but I hear a cow. I went to Davis, that's fine. But
Okay.
do you hear the cow?
No.
Whoa.
Yeah, Michelle here. Michelle and I are hearing it. It sounds more like a lawnmower or a leaf blower kind of noise in the background, subtly, just coming on and off.
I'm gonna mute myself and you guys proceed.
Okay. All right. Can people see now?
We
Or
can
not?
see Angola and the Congo.
Ah, that's where we're getting somewhere.
Excellent, excellent.
We're getting somewhere. Okay. This is actually, I've analyzed a number of maps, and I think I'm just going to be able, in the time remaining, I'm just going to be able to talk about it. This is the radix map. In other words, this is the master map, which was created in 1887 of the West African coast. And this is a scan of it that I did quite some time ago. And then aligned with, georeference in terms of the current day coast of Africa. And part of the reason is that West Africa is actually the first area to undergo large-scale coastal mapping. And since I'm primarily interested in nautical charts, this is one of the areas that's actually originally mapped between 1484 and 1486. In other words, that's what you're looking at right now. And this is the map from 1887. And so the project in part is a comparison of the maps of the African coast, beginning with the very first ones in the 15th century, and then sort of carrying that all the way forward to the 21st century. Anyway, so this is the basic nautical chart that's given out to British sailors, and it's the one from which maps were made through the through the start of the First World War. So there were tiny revisions that were made. And so one of the things that I had originally wanted to do is to find out whether there was any way we could look at changes in coastlines. So in other words, can any of these maps serve as a kind of a guide to looking at global warming? And the answer, unfortunately, as I think this map shows, is no. And if I zoom in for a little bit and show you, these are just simply, these are unnamed places. And what I've done here is to show, this is Cabo Lope Gonzalez, which is actually at half a degree south of the equator. The equator is just a tiny bit north of that. As you can see that the coastline lines up very well up to this point, and then it indents a little too much here, matches here, except for this tiny piece here, matches extremely well here. And this is actually the reason why it does is that this is the Cabinda enclave of Angola, and this is the mouth of the Congo River. And so this area actually maps extremely well onto a contemporary map. But then once you get south of the Congo River, here you have an area where, as before, the coastline is much further inland than the current coastline. And then you get down here, and you have this bay, which is way too far north of where it should be. Here's where the bay should be. Here's where the headland is. This is actually, it's quite interesting because that's actually a very famous bay. Now here we have a coastline where it goes in the opposite direction here. And this is part of Angola. This is the After this is the African coastline map of 1887. And this is the modern one. And you can see the coast is actually way, way further out to sea. Then it alternates and you go back. And then you have this huge section here, which is called the Skeleton Coast. And the reason it's called the Skeleton Coast is because it's a place where it's the oldest desert in the world. It's actually even older than Antarctica. They estimate it's about 55 million years old. And there is absolutely no water anywhere. There's a long story about sort of why water gets caught over here in the Drakensberg Mountains. So at any rate, on this area, the coast is very frequently covered by fog. So what's interesting is that until you had the advent of IR satellite imaging, you never actually got a very good picture of this coastline because most of the time it was covered in fog. I'm switching to this. Now there's an area right to the south of here, which is, oh shoot, now it's gone. It's disappeared from my screen as well. Oh, here it is. No, it's nice and gone entirely. Anyway, so at any rate, this area is Bay of Tigers, this area and through here, which lines up very well. And then you get back down into this area. This is actually an upwelling area, so you have a lot of fish and so on. And then you get back here, and again, you're back into this area where you have the coast not lining up at all. And again, this is areas, with the exception of that are fogged in, and we don't actually have an accurate coastline again until infrared satellites. Then we get to Cape Town, South Africa. And parts of this are extremely well mapped. As you can see here, we line up, but the Cape Peninsula, which is right there, is too far north of where it should be. This is a little bit off, but then when you get down here to the Cape of Good Hope and to Cape Agulhas, which is the southernmost point of the African continent, you actually get something that lines up. So all of these irregularities in the map suggest that there are problems with measurement, with scaling, that's another image altogether, that make these maps not reliable to be sources of good information on coastal sea level rises. I think I'm going to stop right there. I did the same analysis with another map, but I'm not sure it's actually going to show up. This is from the French Département de la Marine, which is the equivalent of the British Hydrographic Office. And you can see that I'm trying to open it there, and since this machine has been crashing on me, I'm not sure that's actually going to come up as well.
Are you opening it within the same Photoshop window?
No, because it's not in Photoshop. It's in Adobe Illustrator.
Okay, then what you'll have to do is share your screen again with the other application.
Yeah.
All we're seeing is a blank screen, right? Well, that little blank.
Yeah,
section.
no, it's not. It's not. Yeah, it's okay. Well, do you see the screen now?
We're still seeing Photoshop. Like I said, you'd have to share the screen again, just change it to Illustrator rather than Photoshop.
Yeah. Hold on a second. Okay. Yeah, no, it's not the Guinea map. It's not loading. I think maybe my computer ran out of memory or something like that, because it's not responding. In other words, the program is opening, but the image is not. So whoops, maybe here it'll come and I'll be able to share it with you. Anyway, this is the 1754 map, actually the area just to the north of it. I have another one, which is actually also from the Département de la Marine in France from 1754, which, like the 1887 map for France, was one of these radix years from which the basic year from which they made sort of minor modifications in subsequent years. So yeah, no, this is like, it's going, not responding, not responding, not responding. Yeah, now it's gone back to Photoshop. So
Okay, I'm sorry.
yeah, no, this is the first time I've had such horrible luck with Zoom and sharing. I mean, it's a long story. I work with some collaborators on this, and we're in 3 different time zones, and we never have any problems. It's just actually all on the West Coast that I seem to be having these difficulties. So I can just answer. I think I'll just have to answer questions about this.
Okay, why don't we save the questions to the very end?
Okay, is that what we're doing? That's fine.
Yeah, again, participants, if you have questions for any of our speakers, please put them in the Q&A. Ryan Horn is back online, crossing fingers. At least I am. And Ryan, did you want to continue your presentation from the Pleiades slide? I think that's where we kind of started breaking up a little bit in your presentation.
Yeah, sure. I'll try that. I'll stay off of video to see if that helps. Again, my apologies, everyone. Just I had an internet crash. What are you going to do? Let's see here. So we're at the Pleiades slide, and I'll try to share my screen in a second. I'm also going to put into Slack the links to the to this presentation. So in case this crashes, I can just, you can follow along if you want. Okay, so let me get back to Zoom. And we will try this. All right, so can everybody see that?
Yeah.
All right.
Yes,
Perfect.
we've got it.
All right, excellent. So we'll try again. So one of the things we're doing in Pleiades as gazetteers is we're actually looking at how things are linked together. And so if we start talking about in gazetteers how, like, the hierarchy of relationships, that something is on an island, or that this particular features in Rome, which is, you know, on this region and so on, we can actually start building networks of geographic relationships. And you can see that mapped here, where all this is Pleiades data, put where it is, connected to other things that it's connected to in our system. And so this is actually a different way of exploring how to, say, make shapes of political entities, and I'll get into that a little bit later, just by how they're connected together. And another gazetteer, I mentioned it, I think this is where we started losing connections. It's World History Gazetteer at the University of Pittsburgh. And all the QR codes give you links to where these things are. And this is a really interesting one because it has a core of historical places, but it's really designed to bring in different projects together. And you can see kind of a list of that. We have China Historical GIS, there's HGIS des Las Indias, the Al-Thuria Islamic Gazetteer, and these are different gazetteers that are all being tied together, connected through linked open data, which we'll get to in a second. And it's browsable. You can bring your own projects in, and you can pull this old data for yourself. So if you have a list of whatever you happen to be studying and you get all the place names, you can bring it into the system and it'll generate the geospatial data for you, which saves a lot of time and effort. And this is a process called reconciliation. And so traditionally you had to build your own database, or if you were somebody like me, had to go through and search for 10,000 Greek place names in Pleiades to make sure they matched correctly. And this was done by hand, and it took a very long time. But then there's this thing called Recogito from the Pelagios project. And what this is, it's a system where you just put in a list of place names, and it searches probably 12 different connected gazetteers, and it tries to find the best match for you. And so here you can see I was doing this with the with Pliny's Natural History, and you can do this in gazetteer lists, or you can just do this in raw text, and it'll produce a gazetteer for you. And so this takes a process that would normally take me weeks. You can get this done in like 2 days now of just going in, checking the matches, and having everything reconciled for you. So this is really a game changer in a lot of gazetteer work are things like Recogito. And right here, this is just, again, very quickly done. This is just a day of work mapping all the things that Pliny mentioned. And you can map it within Recogito, then you can pull it out in whatever data format you want. And this is all built on something called linked open data. And this is where we're getting a little bit away from geography, but it kind of helps you formulate what we're actually building. And linked open data, it's not just geographic, it's all kinds of data. It's all kinds of sources. You can get things from the Getty, Library of Congress, what have you. And what the basic idea is that if you have a URI, which is an ID for like say Athens or whatever, you can have different kinds of discoveries. So you can find coins that are made in Athens. You can find different kinds of texts that mention Athens. All of people are using the same URI. This can be done automatically. This is, I'm not going to really go into too much detail about it, but the idea about linked open data is that it's available. You can read it on a machine. It's in an open format so that anyone can use it, open standards, and that you link to each other. And this is called 5-star data. This is what we're all trying to strive for. And really only within the last, I'd say 3 or 4 years, have we built the infrastructure that you can actually do this. And that infrastructure is based on something called RDF. Again, I mentioned URIs. This seems pretty technical, and it kind of is behind the scenes, but a lot of this stuff has been demystified by things like Recogito, where you can actually link to other people without having to know all the technical details. So that's really kind of nice. And what do you say, so what? But what do you get from all this? Well, let's say we have the Pleiades Gazetteer, which has been the cornerstone of a lot of the linked open data for the ancient world. As long as you have things and you're interested in places, you get all this information from Pleiades, plus you get all the other projects that use that URI. So you get all the other data from everyone else who's participating in this linked open data system, and that's right there on your fingertips. And so I want to give you an example of this thing called Pelagios, which brings together all, I've mentioned for Recogito, it brings together all these different connections, all this different linked open data, and allows you to search it. And this is done through something called the Linked Ancient World Data Institute and Initiative, which you can follow on Twitter. And these are all the different kinds of projects. We have people working on prosopography, on information about individuals, people working on texts, inscriptions. I've mentioned coins a number of times, and we're all using the same data, same metadata. We're all describing things the same way, using the same IDs. And so this is kind of visual representation of that. And it's all built from our original place gazetteer. That's what started all of this. And that's what's really unique about it, is that we have this giant data ecosystem based around simply finding place names in ancient sources. And so, well, what can you do with it? Well, one of the things I want to do is to look at coins and what those can tell you about networks and people and politics. And being a digital humanities person and not wanting to do any more work than I absolutely have to, I can access all these data sources basically for free. That Pleiades gives me the spatial data for all the cities in my study. From the American Numismatic Society and all their various things, I get information about coins, I get information about minting, about hoards where they're buried. I get information from museums that use their data, which I can then connect back to Pleiades. Then I get other data from places like the Ancient World Mapping Center for roads and other kinds of representations. And so what I was doing was looking at a few different cities in Turkey and trying to figure out where the coins go, where the coins are buried, how these relate to political structures. And this is my list. And you can see on the location URI, that's all different gazetteers. And that's how all this stuff's tied together. Some of it's Pleiades, some of it is actually things were in geonames, which were not part of the ancient world, which then I brought into Pleiades later. And so just connecting all these dots gives me something like this, which is, you can see the link here. And this is the Aeolian Alexander's project. And that looks at 3 different cities, all of their minting, all the different kinds of networks, how the coins are related to each other, where they go in space. And I was able to do that through linked open data. Without all these resources, this kind of project would never be done. And what does that give you? Well, hopefully this works. You're about to see several hundred years of coin production and distribution and connectivity in about 3 seconds. And so all of that, and I'll replay it again, is spatial data that I brought together because it was all part of this connected linked open data system. And this is really the first time that we've been able to visualize the hoards, where coins are buried, where coins are produced, where they're going, how they're getting there through different routes that we've identified on different projects. This is really the first time that we've been able to look at this spatially. And that leads to things like this. This is a very traditional map that you'll see in textbooks. It's wonderful, it's beautiful. I don't like it very much because it really shows you, these really big tracts of land that are shaded, which, oh yeah, someone controls it. Not really. If we look at our data, and again, these are all cities, these are routes that we were able to identify collectively. This is what an actual kingdom kind of looks like. This is where the main roads of communication are to the main cities. And you can see, well, Egypt looks very different from here to here. Egypt's based on the Nile. You can see the big connectivity for the Seleucids. Those are the red, that's the red kingdom. You can see the Attalids up in the north. And if you put all this together, again, with other gazetteers, in this case, it was one of garrisons, you can see how political power is actually expressed based on connectivity and based on where these kinds of things are sitting. And you can see an article about it here. And this is just, again, finding linked open data that's out there and applying some of my own research to it. And I was able to figure out here about garrisoning strategy and where they actually are spending money and time and effort by just connecting these dots together, which was a pretty interesting discovery. It showed me that the imperial powers are spending a lot of money on very key areas and then letting the locals waste their money garrisoning places they don't care about. And so it's a really interesting idea about power and authority and money expressed again by linkages. And so that's kind of a very quick and, I'm sorry to say, choppy somewhat overview of what we're actually doing for bringing together linked open data and geospatial maps and how this whole giant digital ecosystem is developing. Thank you.
Thank you, all of you guys, for your sorry, Pat, you're muted there. Thank you for your presentations. We've got just over 5 minutes for questions, so I was going to let Priya lead that. We've got a number in the Q&A for each of you, I believe.
Okay, so do I go down the list?
Yes, I think the oldest are at the top, the oldest questions. There's a timestamp for each.
Okay, for Michelle, did you upload your output? Some of these questions, I'm not sure if they're actually the questions for like reading out loud.
I got you.
I'm
Thank
sorry.
you. The
Michelle,
person,
can you see the Q&A now?
I can.
Okay.
So looks like someone wants to know if for the Central Pacific Railroad project, did we upload our output anywhere? So and suggesting openhistoricalmaps.org. We haven't actually uploaded the data anywhere as much as I would like to. So we've got the trace lines are on the website that I linked in the chat. And so that data is available. But my concern with the scan and georeference maps is that because we had to let it do so much warping, that you actually can't read a lot of the words on the map anymore. The line for the railroad is really visible, which is what we needed for the project, but you can't read anything else. It's like kind of smeary and blurry. So I hesitate to share the end products just because they are so manipulated that I'm not sure you could, well, I couldn't use them without referencing the original just scan, not georeference map. So it's kind of a toss up. I'm not sure how helpful they would be. And also we'd have to make sure that we had permission to share the stuff that was scanned by like the archive and also by Stanford. You do have access to TopoView though, which is where we got the topo maps. Those are freely available and already georeferenced. So that's my short answer to that.
Okay, there's a question for Ryan. Library Do you see it on the?
Yep, I
Q&A?
see 3
Okay.
questions, so I'll just go down
Okay.
in order, I guess.
Okay,
course.
yes, please.
Sure. First question from Craig is Recogito usable outside of the Pelagios network? Yes, it is. The Recogito itself, again, draws from about 12 gazetteers or so. And so some of those are kind of part of the network. Some of them are ones that they've just downloaded and rectified themselves. And the entire code base for Recogito is actually all open source. So you can pull that out and you can modify that. I'm actually working with people to do that now for actually an oral history project that has nothing to do with geography, but is still going to be using the same kind of reconciliation thing. So yes, Recogito is usable outside. And if you want to use it, it's free registration on their site. So it's very open source, very usable. Scott's question has to deal with Mark. And is there any standardized scheme for describing gazetteer listing? And is it the same as the URI? And who can contribute? And also, how accurate is the information? And that's a good question. As far as accuracy, we actually have at Pleiades and the World History Gazetteer editorial boards of experts that will actually look over things that are brought in. Because we've had people before try to say things like King David's tomb is in a cave in Missouri, which we obviously do not want to have on our website. And so we do have a team of experts. We have editorial control, and we do have, basically we treat everything as a micro publication. Anyone can contribute. We have a lot of undergraduate classes that are actually built on adding stuff to the gazetteers. But again, we look over it and we analyze it. There's actually things called the linked pasts initiative, and that's trying to standardize how we use gazetteer data and how gazetteer data is described. So there's linked open pasts would be a good place to look for that. And I can put some of those in the links actually in the chat. So yes, we are working on actually standardized data elements for gazetteers as well. It's kind of crazy. And then finally for Craig, what languages? Well, the tools themselves require 0 coding skills. You just have to be able to turn on the computer and just upload a list of, or even just again a raw text file for Recogito. For how I'm using it, I do a lot of Python programming, and so there's a lot of ways to bring the stuff into a Python or a Jupyter environment and actually run it all there as well. So you have the whole range from you can have absolutely no programming ability whatsoever and use these tools to you're a Python master and you want to tear it all apart and remix it. They run the whole range.
All right, thank you guys. It doesn't look like we have any additional questions, just comments in the chat if you wanted to look through that. Looks like you got all of them. Thank you again for being here and for talking today. And I look forward to the next session will be at 3 p.m. There is a workshop as well as a career panel starting at 3. And please check the website for the links. Let me check the chat. There was one pop-up. Just a comment. Thank you. That it was fun. Appreciate you guys being here. I'm going to stop the recording now.